Hello, and welcome to the IAM Policy Evaluation video series. My name is Matt Luttrell, and this is part one of the series, the IAM Policy Language Explained. Let's jump right into it. What are we going to cover in this series? The video you're watching now is the IAM Policy Language Explained, where we'll go through each of the policy elements, talk about do's and don'ts, and explain how IAM performs IAM policy statement matching. In part 2, we'll dive deeply into IAM policy conditions and look at some helpful condition keys and explain what condition keys to use in various situations. Part 3 will introduce and explain how IAM policy evaluation chains work and show how different IAM policies interact with each other. We'll take a special look at the principal element of an IAM policy in Part 3. And lastly, Part 4 will take all of the learnings from the previous videos and walk through an authorization of an AWS request from start to finish. So what are we going to talk about today? We'll start with an overview of the IAM policy language. We'll work through a statement matching exercise. And then we'll take a look at each of the elements of an IAM policy statement in detail. So let's get started. First, we'll start with an overview of the policy language itself. Here you can see an example of an IAM policy statement. All IAM policies are made up of one or more statements. Within a statement, you have 5 primary elements. The first of which is the effect element, which specifies whether the request should be allowed or denied when the statement is evaluated. The next element is the principal element. The principal element specifies the entity that is allowed or denied access. You'll see that sometimes the principal element is implied and not present in a policy statement. Next, we have the action element, which specifies the action or actions that are allowed or denied. And we have the resource element. The resource element specifies the resource or resources that are the target of the action. Lastly, we have the condition element. The condition element specifies the context under which access should be evaluated. For example, the example statement here only applies if the value for the AWS Secure Transport condition key is equal to true. Now, we just looked at an IAM policy statement and said that IAM policies contain one or more statements. There are also a number of different types of IAM policies. There are policies that are associated with an IAM role, user, or group, and policies that are associated with an AWS resource. For policies that are associated to a role, user, or group, there are identity-based policies, which are policies that are directly attached to an IAM role, user, or group, and contain your fine-grained permissions. There are service control policies, which are policies that typically contain broad guardrails and are used with AWS organizations across many accounts. And we have permission boundaries, which are an advanced policy feature that is typically used to delegate the creation of IAM entities. We also have session policies. Session policies are policies that are applied to an individual session when you assume an IAM role. Now, as for policies that are associated with an AWS resource, there are resource-based policies, and resource-based policies are policies that are attached directly to resources, such as an S3 bucket or an SQSQ. And then we have VPC endpoint policies, and VPC endpoint policies are policies that can control who can use and access a particular VPC endpoint. Now, all of these different policy types are made up of one or more policy statements. Let's expand a bit more on policy statements. Shown here is a typical policy statement that is associated with an identity, starting with an optional statement ID value that we did not touch on earlier. And this is just a unique identifier for the statement, and it's an optional value. Then we have the effect, the action, and the resource. These are the 3 important and required elements of a policy statement associated with an identity. Lastly, we have the condition, and the condition is optional. And you use the condition, like we mentioned earlier, to scope the policy down even further and say that this statement applies under these conditions. You might notice that there's no principal element here. Now that's because the principal is implied, since the policies themselves are associated with the principal. A resource-based policy has the same elements that an identity-based policy has, but with the added requirement of a principal element. That's because any principal can attempt to make a call to a resource, and it's up to you to use the principal element to define who can or cannot access your resource. You'll also notice an asterisk by the required pointing to the resource element. And this means that the resource is implied and optional in some resource-based policies, such as an IAM role trust policy. In most cases, you'll see this resource element, however. Now, we've been focused on a single policy statement up to this point. And here's an example of an entire IAM policy that has multiple statements. You'll see the addition of a version element and then a statement element, which contains the array of your statements. So we've learned about policies, we've learned about statements. Now, how does IAM take our policies and statements and determine if access is allowed or denied? And that's where an exercise that I'll call statement matching comes in. But first, let's review a few important rules of policy evaluation. Rule number 1, at least one statement with an effect of allow must match for a request to be allowed. And rule number 2, a matching statement with an effect of deny takes precedence over a matching statement with an effect of allow. It also does not matter what order you write your policy statements in. If a statement with an effect of deny matches at any point, the request is denied. Now, what do I mean by matching? In order to go through the statement matching exercise, we need to have something to match against. This is where the authorization context comes in. When you make a request to AWS, we build information about that request and put that information in this big property bag. This includes information about who is making the request, the target of the request, and even some values that you supply, like tag keys and tag values. IAM then compares this authorization context to your IAM policies to determine which policy statements match, and in the end, if a request is allowed or denied. Now, don't get too caught up on the exact values that you'll see in these examples of the authorization context. They're just for illustrative purposes to help you understand how statement matching works. You should use the IAM documentation to determine what a particular value will look like in the authorization context. Let's start with our first statement matching example. In this example, John uses his IAM role to get the object myfile.txt from the bucket example bucket. The role making the request is John. The resource targeted in the request is the myfile.txt object that lives in the example bucket. And the action that John is attempting to perform is S3 get object. Throughout these examples, we assume we have this identity-based policy attached to John's role that has these 4 statements. Now, don't worry about memorizing these statements. We'll show them individually throughout the matching exercise. Here's an example of what the authorization context could look like for John's attempt to perform a get object request against an S3 object named myfile.txt. You can see that the authorization context contains the action that John's principal is attempting to perform, the resource that John is attempting to perform that action against, and some additional context associated with the request. An actual request would contain more context than what you see here, but we're keeping it simple for these examples. You can also see that the request includes a unique ID for John's IAM role in this principal field. To determine if the request is allowed or denied, IAM will compare this authorization context against the policy statements attached to John's role. And IAM will also compare the authorization context against other policy types that we mentioned earlier. But for this exercise, we're just focused on John's identity-based policy. Let's start by comparing the resource in the authorization context with the resource in our IAM policy. The asterisk that you see in the resource is a wildcard value that will match any text, so we can see that the resource is a match. Now let's look at the action. We see that we have S3 get object in the authorization context, and we also have S3 get object listed in our IAM policy statement. So the action matches as well. Because both the action and resource match, we can say that this statement matches. So then we look at the effect of the statement and we see that it's an allow. Now you can start to see how authorization is really just this elaborate string matching exercise. And you might think, okay, we found a matching statement. We can stop this exercise now and the request is allowed. But remember that an explicit deny always takes precedence over an explicit allow. So we have to keep going. Let's look at the next statement in our policy. We look at the resource in the authorization context and the resource in the policy, and those resources match. We look at the action and the action in the policy. Those don't match, so we say that statement 2 does not match. Let's look at the next statement. Now, statement 3 is interesting because we already have a statement that allows the request, and we only need one matching allow statement for the request to be allowed. So for the purposes of this exercise, we can just skip this statement. And statement 4 is the same way. Again, another allow statement, and we don't need to look at it, so we'll ignore statement 4. So to determine the result of the evaluation, we only need to look at the statements that match. And for this request, only statement 1 matched our authorization context, and the effect for statement 1 was allow, so we can say that the request is allowed. Let's move on to request 2. In request 2, John uses his IAM role to create the bucket example bucket. And again, the role making the request is John. The resource targeted in the request is the example bucket. And the action performed by John is the S3 create bucket action. We again compare the authorization context to the request. And this is interesting. It may look like the resource matches here, but remember, we're just comparing strings. And the resource in our authorization context does not have a forward slash that the resource in our policy has. This forward slash is used with an S3 bucket to reference an S3 object and not the bucket itself, which is the resource in our authorization context. So we can say this statement does not match. We move on to statement 2. Look at the resource matches. We look at the action does not match. Statement 2 does not match. Let's look at statement 3. Look at our resources, the resources match. We look at our actions, and again, the action does not match. So statement 3 also does not match. What about statement 4? We look at our resource, and in this case, our resource does not match. So statement 4 does not match. So if we look at the evaluation results for this request, we can see that none of our statements match. So what happens? This means that request 2 is implicitly denied. Remember, you must have at least one matching allow statement for a request to be allowed. So because there was no matching allow statements, this request is denied. Now let's take a look at one more example. In this example, John is again using his IAM role to put the object myfile.text to the bucket example bucket. The role making the request again is John. He's targeting that myfile.text object, and he's trying to perform S3 put object this time. So let's go through our statement matching exercise. The resource matches here as well. This time we have the forward slash in the authorization context since we're referencing an S3 object. The action matches. We look at the effect is allow. We have one matching allow statement. Let's look at statement 2. The resource matches. The action in statement 2 matches this time. We look at the effect. We see that the effect is deny. So statement 2 matches with an effect of deny. Now, once we found a matching deny statement, we can actually ignore any other statement. But similarly, once we find a matching allow statement, we can ignore allows as well. So we'll ignore statement 3. We can ignore statement 4. And we get back to our evaluation results table. Now we have two matching statements this time, one allow and one deny. Because a matching deny statement always overrides a matching allow statement, we say that request 3 is explicitly denied. So let's review our possible policy evaluation results. We have explicit allow that we saw in request 1, and that says that at least one matching allow statement and no matching deny statements exist. We have the implicit deny that we saw in request 2, and that means that there are no matching allow or deny statements. Nothing matches. We have explicit deny that we saw in request 3, and that means at least one matching deny statement. It doesn't matter how many matching allow statements we also have, but at least one matching deny statement means the result of the evaluation is an explicit deny. You'll notice that there is no implicit allow, and that's because a request must always have a matching allow statement to be allowed. So now that you have an understanding how a statement matching works, let's take a deeper look at each of the elements in our policy statements. Starting with the simplest element, the effect element. The effect element, as we mentioned, is a required element, and it specifies what the result of the matching statement is, as we just saw. Now, the reason it's the simplest element in an IAM policy, there are only two options. It's either allow or deny. And remember, again, that a matching deny statement always overrides a matching allow statement. The action element is a required element that describes a specific action or a set of actions that will be allowed or denied. This example statement shows how the action element can include more than one action, and this statement will match if any of these actions match. We would say that a set of actions is evaluated as a logical OR. Now, there are multiple representations allowed within an action element. An action is divided into two parts, the service prefix on the left of the colon and the name of the action on the right of the colon. The asterisk that you see here, and we'll see in other elements as well, represents a wildcard, which means that it matches all characters. This allows you to match more than one action based on some sort of naming convention. So you can specify the action directly. You can put the wildcard at the end of the action, or you can put it at the beginning of the action. You can even put a wildcard on both sides. You can specify the wildcard immediately after the colon as well, which represents all actions that belong to the specified service. Or you can use a wildcard by itself to specify all available actions. Take extra care when using a wildcard by itself. This should only be done for highly privileged principals. Now, what you can't do, however, is use a wildcard for the name of the service. And both the service prefix and the action name are case insensitive in IAM policies. The action element also has an inverse variant, the not action element. IAM policies must either include an action element or a not action element. A not action element allows you to build an exception list by matching all actions except for the actions listed in the policy. Not action elements should primarily be used with an effect of deny, and this can be a good way to build an allow list in something like a service control policy, where you explicitly deny actions that do not appear in the not action list. The policy statement that you see here is an example of this, with an effect of deny that says that IAM should deny any action that does not belong to the S3 or EC2 service prefix. So if we think about applying this policy to all possible services, our mental model might look a bit like this, where the services in red are explicitly denied, along with all of the other services that are not listed. Now, we still haven't allowed any actions with this policy statement, but we've explicitly denied every service except for EC2 and S3. So using not action with the deny is a common pattern in service control policies to build this allow list. Now, what about a not action with an allow? Now, this policy might make sense at first glance. Maybe I'm an admin and I'm trying to write a policy to stop someone from creating a role. But what actually happens when you write a policy like this? In green are the actions that I've allowed when I write a policy like this. And you can see that you end up allowing every action except for the single IAM create role action. And there are thousands of actions. So this is effectively an administrative policy. If you find yourself using not action with an allow statement, think very carefully about what you're trying to do. Most of the times there are better ways to write that policy. A quick note that not action is technically a logical NOR, which is what allows it to behave like an exception list when you have multiple actions listed in the not action element. This means that this statement will match and deny any action that's not S3 get object nor S3 put object. Now, one important action I want to highlight is IAM pass role. This action allows or denies the ability to give an IAM role to an IAM service or an AWS service. The AWS service is then able to use that IAM role on your behalf. APIs that require IAM pass role usually take a role ARN as a parameter. If you're not familiar, an ARN is a unique identifier for an AWS resource. Now, the roles that you're passing must be in the same account as the resources they are passed to, and you really need to take extra care to control who can pass what role to an AWS service. Now, here's an example of the Lambda create function API that takes a role ARN as a parameter and therefore also requires the IAM pass role permission. That means that if I tried to create a Lambda function, I would only be able to create one that uses IAM roles that I have permission to pass by way of the IAM pass role action. Another note on actions is that when you make a call to an AWS API, that API will authorize one or more IAM actions. These IAM actions usually share the same name as the API, but there are some exceptions. One example of an exception is the S3 copy object API, which requires the S3 get object permission on the bucket you're copying from, the S3 put object permission on the bucket you're copying to, as well as the S3 list bucket permission. There are also APIs where the IAM action has a slightly different name than the API, such as Lambda's invoke API that requires the Lambda invoke function IAM action. So double check the documentation to figure out the exact IAM actions you need to call a particular API. Moving on to the resource element. The resource element is a required element that describes a resource or set of resources against which the actions in the statement are allowed or denied. Resources are specified using Amazon Resource Names, or ARNs, which we said were unique identifiers for AWS resources. Take a look at some example ARNs on the slide. Notice that not all resources include every part of the ARN. An S3 bucket, for example, does not include an account ID or a region. An IAM role does not include a region. So once again, you should reference the documentation to figure out what the proper ARN format is for the resource that you're referencing in your IAM policy. You can also use wildcards for the resource element. The first example here would match any resource. The second example would match an EC2 instance in any account in any region, but only in the AWS standard partition. And the third example would match an EC2 instance in the all ones account, but in any region in that AWS standard partition as well. And the last example here matches a very specific IAM role and only that IAM role. As we saw with the action element, if a statement has multiple resources, they are evaluated as a logical OR. This statement allows the IAM get role action on role 1 or role 2. Also, like we saw with the action element, the resource element has an inverse element that can be used in its place. You can also think of the not resource element as an exception list again. This statement reads, deny S3 get object and put object to all resources except the objects in example bucket. Like not action, not resource is typically used with a statement that has an effective deny. Not resource also evaluates as a logical NOR when there is more than one resource in the not resource element. This statement denies S3 get object action as long as the resource is not example bucket 1 nor example bucket 2. And once again, with not resource this time, be very careful about using the not resource element with an allow effect. Using not resource with an allow effect will grant access to every resource except the resource specified in the not resource element. On to the condition element. The condition element is an optional element that lets you specify when a policy statement is in effect. This policy statement allows an S3 get object request to the example bucket resource, but only if the request is made using TLS. Adding that but only if to the end can be a helpful way to read policy statements that have conditions. Let's start with the definitions of different elements that make up a condition. The operator defines what comparison IAM should perform to attempt to match the values in your policy with the values in the authorization context. The key defines which value in the authorization context IAM should look at for the comparison. And the values are either a single value or a set of values that must match the value in the authorization context for a statement to match. There are a number of different condition operators, and which condition operator to use depends on the type that the value has in the authorization context. You can also use different suffixes on an operator, such as equals and like, to do exact matching and wildcard matching respectively. You can also add not to many of these operators to invert them. We will dive deeper into many of these operators later in this series. There are also what are called multi-valued qualifiers. These qualifiers can be combined with condition operators to make comparisons against keys in the authorization context that have multiple values. Most condition keys can only ever have a single value in the authorization context, and most condition keys are not multi-valued. You should only use multi-valued qualifiers for those condition keys that can have multiple values in the authorization context. So how do we figure out which condition keys can be used with which IAM actions and resources? That's where the service authorization reference comes in. The service authorization reference is an IAM documentation page that documents a particular service's authorization design. I would strongly suggest bookmarking this page if you find yourself writing IAM policies. There's also a section on each page which lists what we call service-specific condition keys and their types. The types here tell you which operator you should use to perform the comparison. A condition key that has a type that starts with array of indicates that the condition key can have multiple values in the authorization context, and that you should use a multi-valued qualifier to compare it, so either for all values or for any value. There are also condition keys that work across all AWS services that start with AWS:. These condition keys and their types are documented outside of the service authorization reference in the IAM documentation. Now that you've seen condition operators and their types, let's take another look at the authorization context. You can see that we've got a few different types of context values here. AWS Principal Org ID is a string value, and you should use the string operators to match this value. AWS Principal ARN is an ARN, and you should use the ARN operators. And AWS Secure Transport is a Boolean, and you should use the Boolean operators. In blue, I've highlighted all of the single valued keys in this request. Remember that a single valued key is a key that can only ever have 0 or 1 value in the authorization context. In orange, you can see that the only multi-valued key in this request is AWS tag keys. This is the only key in this particular request that may have multiple values. This means that this is the only key that you should use the multi-valued qualifiers for any value and for all values to match in this particular authorization context. Let's switch gears slightly and look at the Boolean logic of how condition keys are evaluated in more depth. Now, these are just examples designed to get a point across. Don't get too caught up in the actual condition keys and values that I'm using here. These aren't intended to be example policies that you should use in your environment. The focus here is really just on the Boolean logic. Okay, so first off, values for a condition key are ORed. This policy allows the creation of an IAM role if the tag in the request with a key of team has a value of team A or team B or team C. So values of a condition key are evaluated as a logical OR. Values for a condition key that include a not comparison are NORed. The policy denies the creation of an IAM role if the tag in the request with key team does not have a value of team A, nor team B, nor team C. So this is your way to write an exception list with a deny statement. Now, all condition keys in a request are logically ANDed together. This is true even if the operators have different names, as shown in this example with string not equals and string not like. Each condition key must evaluate to true independently for the policy statement to match. This policy allows the creation of an S3 bucket if the principal belongs to the all ones account and the request originates from VPC ABC123 and the value of the tag on the principal with key of team starts with team. Again, don't get too caught up with the actual condition values here. Focus on the Boolean logic. Condition keys that contain a not are still ANDed together, though it can be tricky to follow some of the double negatives without a pen and paper at times. This policy denies the creation of an S3 bucket if the principal does not belong to the all ones accounts and the request does not originate from VPC ABC123 and the tag on the principal does not start with team. We'll go much deeper into the condition element later in this series, but for now, hopefully this was a helpful introduction. Lastly, let's briefly touch on the principal element. Again, we'll go much deeper into the principal element later in this series as well. The principal element is a policy element that's only available on resource-based policies and VPC endpoint policies. It defines what principals can access the resource. There are four possible types for the principal element: AWS, federated, service, and canonical user. Only a few use cases in AWS still require the use of canonical user, so we're not going to talk much about it. You use the AWS principal type to reference other accounts, roles and users, and session principals. This is the most common principal type and the one you will use to grant access directly to AWS principals that belong to you, or even grant cross-account access to other trusted accounts and trusted principals. Now note that these two representations of the account are exactly the same. They are just two different ways to write the principal element in the account. Write the account in the principal element. The service principal type is used on a resource to allow access to an AWS service. When you write a policy that uses the service principal type, you should usually include a condition key that specifies either the source ARN or the source account that the request originated from. This is to prevent against the confused deputy problem, which we'll go into detail more about later in this series. And lastly, federated principals are only used in IAM role trust policies, and they are used to grant access to a web identity session principal from a web identity provider or a SAML session principal from a SAML provider. The policy shown here provides access to users federated with the SAML provider listed in the principal element. You'll want to take a look at the documentation to determine what condition keys to include when creating an IAM role trust policy using a federated principal, because it can be use case dependent. Now, a wildcard by itself in the principal element is a legal value, but be very, very careful before you do this. This policy makes example bucket accessible to anyone on the internet, not just your principals. There are few cases that require a wildcard in the principal element when used with an allow effect. Using a wildcard with a deny effect, however, is safe and is usually a good idea. But be very careful using a wildcard in the principal element with an allow effect. So you might think, okay, I'll add a condition to limit access to only principals with a certain tag, and I'm good. The problem here is that this policy still applies to anyone, not just your principals. anyone can add the same tag to their principal and still access your bucket. Don't do this. We'll touch on a few valid use cases for using a wildcard in the principal element with an effective and allow when we do the deep dive on principals later in this series. But for now, the takeaway is that you should be very careful with the wildcard value in the principal element when used with an effective allow. Now what happens if I just try to wildcard a portion of the principal element? Yeah, this doesn't work. This is not valid syntax. The only wildcard that is supported in the principal element is a wildcard by itself. When you need to use a wildcard to reference a group of roles or a particular role naming convention, you can use the AWS Principal ARN condition key instead. Take a look and note that this policy also has a deny effect, which is how I would recommend you use this pattern. There are better ways to do this with an allow effect that again we'll cover in the principal series. Like the action and resource element, there's also an inverted element for the principal element, the not principal element. The difference with the not principal element is that there's not really a great use case for it today. I would generally recommend avoiding the not principal element altogether. The policy statement that you see here seems to make sense. I want to deny every principal except for my role. That's the only principal that should have access to this bucket. But this doesn't quite work as you'd expect, for reasons that are out of scope for this presentation that we'll cover in the principal deep dive. For now, just know that the recommended way to write that kind of policy is again using the AWS Principal ARN condition key. This policy that you see here will work as you'd expect and deny all principals except for my role. You should not use not principal with an effective allow. This statement says that it allows all principals except for my role. This includes principals outside of your AWS account that do not belong to you. This is effectively the same thing as using a wildcard with an allow in the principal element. This will allow anonymous access to your resource. You should avoid writing statements like this altogether. So we went through a lot here today. We learned about each of the individual elements of an IAM policy. We learned how IAM does statement matching between the authorization context and your IAM policies. We also learned some basic rules of policy evaluation, like explicit denies taking precedence over an explicit allow. And we scratched the surface of the principal element, and we learned that the AWS Principal ARN condition key has a lot of uses and is a good alternative to not principal. So what's next? In part 2, we'll go deep on various policy conditions and talk about how and when to use them. Part 3 is our deep dive on the principal element, where we'll also introduce policy evaluation chains, which will help you understand how the different IAM policies factor into the authorization result. And then part 4, we will put everything together and we'll walk through an authorization request from start to finish. And with that, thank you, and I hope to see you in the next video.